Hello, and thanks for clicking on this next Prenarculus production. Today, we are going to graph all 6 of the parent trig graphs. So we know we work with 6 trig functions in this course: sine, cosine, tangent, cosecant, secant, and cosecant, and we are going to show you the graphs of all 6 of these to give ourselves an idea as to how we would actually go about transforming these graphs. So we're going to start with the 6 graphs, and then we're going to go ahead and we're going to transform them into whatever it is we want to do next. So let's get started. And we're going to start right away by making a graph. We are going to graph y equals sine of x. All right, so now to graph y equals sine of x, we would need to take a look. We're going to do this on the coordinate plane with an xy axis. All right. We're going to go through one cycle of this graph. We're going to talk more about what a cycle is or a period is in just a couple of minutes. To do this, obviously, we're going to need to know points on this graph. Now, points on the trig graphs are a little bit different. The x value, which goes to the left and right, is an angle measure, right? So, for example, I would have to put a pi over 2 in here for me to figure out the sine of pi over 2, or pi for me to figure out sine of pi. The y value is the ratio that you get from the trig function, right? So let's show you a couple of examples here. We're going to do the quadrantal angles, okay? So for example, if I asked you to find for me, I said y is equal to the sine of 0. So you go on your unit circle, start on 0. 0 is at the point 1, 0. Sine's the y coordinate 0. So that would give me 1 point on my graph at 0, 0. The next quadrantal angle is pi over 2. So the sine of pi over 2, well, pi over 2, that's up here. That's at the point 0, 1. So the sine of pi over 2 is 1. So that gives me another point on my graph. Oops. The x-coordinate is pi over 2. That's an angle. And the y-coordinate is 1. That's the ratio you got from this unit circle. Okay, if we try y equals sine of pi, pi is the angle over here. It's at the point negative 1, 0. Sine of pi is 0. So at pi units, you get 0 for your answer. If we go to sine of 3 pi over 2, so 3 pi over 2 is down here. That's at the point 0, negative 1. The point 0, negative 1, the y-coordinate is negative 1. So we have 3 pi over 2, comma, negative 1. And then if I did 2 pi, well, 2 pi takes me back here again. At the point 1, 0, the y-coordinate 0. That's the point 2 pi, comma, 0. Okay, so these are my points, my xy coordinates, using this trig function, or this definition for the trig function y equals sine x. Okay, x is the angle that you're getting or you're plugging in, and then the y value is the ratio, in this case, from the unit circle that we're using to get the sine of that angle. All right, in this case, it was the y coordinate. All right, so now what we're going to do is we're going to graph these points here. We can graph things like pi over 2 and pi and 3 pi over 2, 2 pi. We can graph all those on the x-axis. All you got to do is remember pi is about the number 3.14. So we're going to 3.14 comma 0. Pi over 2 would be like 3.14 over 2 comma 0. So that's like 1.57 comma 0. Okay, so we're not actually going to graph these decimal values. We're actually going to graph the exact values. Pi over 2, pi, 3 pi over 2, and 2 pi. So I'm going to mark my graph here at 0, and then I'm going to mark it again here at pi over 2. Remember, my angles are on the x-axis. Then we have pi. We have 3 pi over 2. And then we have 2 pi. Okay. 0, 0 is a point on my graph. And then I have pi over 2 up 1. So that's a point there. Then I have pi comma 0. So I'm just graphing these points. 3 pi over 2, negative 1. And then finally I have 2 pi comma 0. All right, so there's my 5 points. Now, obviously there are other angles between these things, right? Like, so for example, if I asked you for the sine of pi over 4, you would say, oh, that's radical 2 over 2. So there's a point pi over 4 comma radical 2 over 2 on my graph. All right. Pi over 4 would be halfway between 0 and pi over 2. So it would be like right here. And then radical 2 over 2, well, radical 2 is like 1.41 over 2. So that's just a little bit bigger than a half, right? 1 over 2 would be a half. 1.41 over 2 is bigger than a half. So it's, let's say it's somewhere right here, wherever that may be. Now, you can fill in the other points as well. And if you do, throughout the unit circle, use all the angles off the unit circle. And if you do, what you're going to get is you're going to get this curve. Comes back down, reaches a low point, it's back up, and we're going to stop here at 2 pi. So what we have here is we've graphed y equals sine of x. This is one cycle or one period of the graph y equals sine x. Now, why do we call it a cycle or a period? Well, think about the unit circle. Let's say you go beyond 2 pi. If you go beyond 2 pi, you just start all over again, right? There's not going to be anything different. You literally just start all over again. So you'd start graphing here like you were at 0, and then you'd make another graph that looks exactly like the one that we just made, right? Because the unit circle, you just go around in circles. You get the same answers again. You just keep going around. Let's say if you were to go into the negatives, it would be the same thing, right? So you'd be coming down here. You'd just be going backward. Okay, so we refer to this from 0 to 2 pi, or any of these that I just drew, as one cycle or one period of the graph. The graph just repeats on itself over and over and over again. So we're going to ask you to be graphing one cycle or one period of each one of these when we start making transformations. Okay, so the other thing you can look at is if you start from 0, you can see that from 0 up to 1, okay, this is the maximum, right? And then from 0 down to -1, -1 is the minimum. That's the lowest point on this graph, all right? This distance is referred to as the amplitude. So we're going to actually define these words on the next slide. All right, this is the amplitude. And then the last thing I need you to see is the pattern. So there's a pattern to the sine of x, y equals sine of x. All right, the pattern is, if you look at a cycle, it begins at the middle, then it goes high, then it goes back to the middle again, then it goes low, then it goes back to the middle, right? Middle, high, middle, low, middle. That's going to be really important when we actually graph the transformations. Okay, so this is what the graph of sine of x looks like. One cycle of it would be from 0 all the way over to 2 pi. That's one cycle or one period. Okay, the period of this graph is 2 pi. It takes 2 pi units to go through one whole cycle before you start all over again. This is going to be really important for your ability to make the graph. You need to be able to tell me the period of each of the parent trig functions, as well as the pattern of them and what their shape is, what they look like. Okay? All right, so let's go through some definitions here real quick. We have them here. So the period is the length of one cycle of the curve. We just did that on the sine graph. Okay, the periods can vary. They don't have to be 2 pi every time. Sometimes they are, sometimes they aren't. Depends on the trig graph we're looking at. The amplitude for sine and cosine, and although we will use amplitude in the other graphs as well for something a little bit different, is the vertical distance from the midline. So the midline was like your x-axis. That's where the middle was on the last graph. That's where the middle was. We call it the midline. To the max or the min. So this distance here was 1 unit. That's the amplitude, how high the wave is. The wave is 1 unit high. All right. And then to graph a transformation of the trig function, which is what we're going to do, we got to talk about all the parent graphs here on this video. You need to know the period, the starting value of a cycle, and the shape of the parent function. The sine function starts on 0, right? It starts at 0 and then works its way from there. Okay? All right. Let's go ahead and let's go get into cosine. So for cosine, we're going to do the same thing that we just did. We're going to look at the quadrantal angles. So if we had y equals, and I asked you for the cosine of 0. The cosine of 0, that's 1, right? You can get it right from the unit circle. Again, the cosine of 0, here's 0. Let's just make sure everybody understands. Cosine is the x-coordinate, so we're actually looking at the x-coordinate because that's the ratio off the unit circle that we need to get the y value. I know it's a little confusing. So the cosine of 0 is 1. So x is the angle, which is 0. The y value that you get with it is 1, right? That we're going to graph. But that y value came from the x-coordinate on the unit circle. Okay? So if I ask you for the cosine of pi over 2, you would tell me that's 0. That gives me a point, pi over 2, 0. If I ask you for the cosine of pi, you'd tell me it's negative 1. That's the point, pi, comma, negative 1. If I asked you for the cosine of 3 pi over 2, that's 0. So that's 3 pi over 2, comma, 0. And then if I asked you for the cosine of 2 pi, you would tell me that's 1. Again, you get 2 pi, comma, 1. And with that, we can make the graph of one cycle of this curve. So we're going to graph 0 on my x-axis, pi over 2, pi, 3 pi over 2, and 2 pi. So we're going to go to 0, 1, make a point, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi, 1. And if we connect all these, again, you can see you get a curve. Looks kind of like that. Okay, what happens after this? It starts all over. So from 0 to 2 pi, that's one cycle or one period of that graph. So the period of cosine is 2 pi units. It takes 2 pi for it to go through one cycle. Okay? Let's see. We have the amplitude is 1 unit high and 1 unit low. Okay? This graph would start at x equals 0. That's important. You're going to need that as well to go ahead and make the graph. All right. And the pattern of cosine is high, middle, low, middle, high. High, middle, low, middle, high. That's the pattern. That's important. That's going to help you to create the final curve. Okay, so now we've graphed sine and cosine. So now, if you know how to graph sine and cosine, you actually almost know how to graph secant and cosecant. Okay, so here's how we're going to graph secant and cosecant. And this is actually how we're going to do it when we go and do the transformations. All right, so what I'm going to do is cosecant is the reciprocal Missing a P there. Reciprocal of y equals sine x. So what I'm actually going to do is I'm actually going to graph y equals sine x. All right, so here's a little practice. So we got 0, we got pi over 2, we got pi, we got 3 pi over 2, we got 2 pi. Okay, amplitude is 1, negative 1 before transformations. Sine, the sine graph is middle, high, middle, low, middle. Now I'm going to graph it dashed because this is not the graph of cosecant. So I'm going to graph it with a dashed line instead of solid. And then I'll show you what cosecant looks like. Now cosecant is the reciprocal of sine. So basically, right, it's almost like sine being flipped over. But I've got to show you how. There's a little bit of a trick to it. So the first thing you need to know is, for example, when sine, so y equals sine x is dashed, right? When y equals sine x is 0, the cosecant, well, cosecant is 1 over sine. So that means cosecant would be 1 over 0. But 1 over 0 is undefined. Undefined means that there's a vertical asymptote on the graph. So that means there's going to be a vertical asymptote on cosecant whenever sine is 0. So we got a vertical asymptote there, we got one there, and we got one here. So there's 3 vertical asymptotes. Now, sine and cosecant share the high point and the low point. They share it in common. And that should make sense because if the sine is 1, then cosecant is 1 over 1. It's 1. It's the same value. Same thing down here. Sine is negative 1. Cosecant is 1 over negative 1. It's negative 1. So now, what we want to do is cosecant is like sine being flipped over. So the easiest way to really think about it is if you take this wave here, this piece of the wave, and flip it up so that it goes to infinity, you get what looks like a parabola. That's the graph. And then over here, on this minimum, you would take the wave and flip it down. If you flip it down, you get a parabola that looks like that. This is the graph of the cosecant. Okay? If I remove the dashed pieces that I used to make sine, that's the graph of cosecant right here. Literally, this is the parent. Okay? The period is, again, 2 pi. All right? Now, we don't talk about the amplitude of cosecant because the waves don't get a certain amount high, right? Or high or low, okay? But the amplitude's important because it tells you where the max and the min are on sine, which helps you to make your parabolas for cosecant, okay? The pattern for cosecant is asymptote, high, asymptote, low, asymptote. But to be honest, we're not even going to use the pattern. When we go and graph these with transformations, you're actually going to draw the sine graph. You're not going to draw the cosecant graph. You're going to draw the sine graph first and then use it and turn it into cosecant. So what's important here is that you understand how we took that sine graph that I had and turned it into cosecant. So when the sine was 0, I flipped it over, got 1 over 0. That made asymptotes for me. And then I took my wave, reflected it up, that gave me this parabola that opened up. And then this wave that opened down, or this wave that's a minimum, I flipped it upside down and it opened down. Okay? That's what we're actually going to do. We're going to do the same thing for secant. So, for secant, it's the reciprocal of cosine. And we're going to do literally the same thing we just did on the previous slide. Now, let's go ahead and let's see if we can review a little what cosine looks like. So we start on 0. We have pi over 2, pi, 3 pi over 2, 2 pi. We're going up to 1, down to negative 1. We got high, middle, low, middle, high. So I'm going to draw it dashed. There's my dashed line. That's cosine. Okay? Y equals cosine is dashed. Now to graph cosecant, we're going to do the same thing. When cosine is 0, there's a vertical asymptote for secant. So there's 2 asymptotes in there. And then they share the high point and the low point, the 2 graphs. So if I take this piece of a parabola and flip it up, my graph looks like that, just one piece of a parabola. In the middle, it actually makes a full parabola that opens down, flip it down. And then on the right-hand side, it's the other half of the parabola that we drew on the other side. Flip it up, and it rises to the left. The period of this graph is, again, 2 pi. It takes 2 pi to go through one whole cycle. Okay? And again, the pattern is high, asymptote, low, asymptote, high, which you really don't even need to know. As long as you know the pattern for cosine, you can turn it into secant. That's what we need you to be able to do. Take cosine, turn it into this. Okay? That's the graph of secant. That's all there is to it. Finally, there's tangent and cotangent. Tangent and cotangent are a little bit different. All right? For tangent, we want the graph to start at an asymptote. There's 2 asymptotes. There's asymptotes in each cycle of tangent and cotangent. Okay, so we want to start at an asymptote and stop at an asymptote. So to do that, the first point we're going to evaluate at is actually negative pi over 2. And you'll see why. Negative pi over 2 would mean to go clockwise down to this point. This point is the point 0, negative 1. Tangent is the y-coordinate over the x-coordinate for the ratio. We got negative 1 over 0. That's undefined. So at negative pi over 2, there's going to be a vertical asymptote on our graph. That's what we're going to make there. All right, let's keep going through the quadrantal angles, and we'll see kind of what the graph looks like. Tangent of 0. If we go to 0, that's the point 1, 0. Tangent's y over x, so 0 over 1, that's 0. So there's a point there on 0, 0. If we go to pi over 2, we have 0, 1. That's put a 1 over 0. That's undefined again. So at x equals pi over 2, there's another vertical asymptote. All right, so let's fill in what we have so far. We're going to start on negative pi over 2. So this is the first time we're actually going to go on the left side of the y-axis here. We got negative pi over 2. Then we got 0. Then we got pi over 2. So negative pi over 2. I'm putting an asymptote there. Pi over 2, I'm putting an asymptote. And then 0, 0. All right, now we need a couple more points because this is not enough. So to get them, we take the easiest tangent values that we know. We need one between negative pi over 2 and 0, and another one between 0 and pi over 2. So we'll do the one between 0 and pi over 2 first, because I think it's a little bit more obvious for you folks to see, and that would be tangent of pi over 4. Because at the point pi over 4, you're at the point root 2 over 2, root 2 over 2. But if you divide those, you get 1. So there's a point at pi over 4, 1. So halfway between 0 and pi over 2 is pi over 4. And I have to go up 1 unit and make a point. And then we're going to go to negative pi over 4, because that's going to be between negative pi over 2 and 0. So if I go to negative pi over 4, I'm down here. That's going to be the point root 2 over 2, negative root 2 over 2. So if I divide those, I actually get negative 1. So that gives me the negative 1 down here. And now if you, again, we're filling in, by making this graph, we're filling in all the other points from this unit circle that you don't see. I'm not writing them all down. I'm just picking a few key points, so to speak, to make my graph. And what you get is you actually get what looks like a cubic, like x cubed, in between two asymptotes. Okay? In between two asymptotes. All right? The period of tangent is pi. It only takes pi units to go through one cycle. You can see that. Okay? We went from here over to there to finish one whole cycle. So we only went halfway around the unit circle, or halfway around the circle. So we only went pi units. The period is pi. Okay? The pattern is asymptote, low, middle, high, asymptote. That's the pattern that we're going to use. And the start for this is negative pi over 2. This is the only start value that differs of the 6. The other ones all start at 0, except for tangent. Okay? So that's different. That's a key. Yeah? All right. We're going to be graphing those. Okay? And then finally, we're going to graph cotangent. We're going to do the same thing, except this time we're able to start on 0. 0 is the point 1, 0. So if I find the cotangent of 0, I get cotangent x over y. So that's 1 over 0. That's undefined. So x equals 0 is now the vertical asymptote. And then we're going to go from there. So we're going to use pi over 4 again. Cotangent of pi over 4 will be 1. So that's the point pi over 4, 1. Cotangent of pi over 2. Pi over 2 is at the point 0, 1. It's x over y, so that's 0. And then we have cotangent of 3 pi over 4. 3 pi over 4, that's the point negative root 2 over 2, root 2 over 2. So my value is going to be negative 1 there. So we got 3 pi over 4, negative 1. And then the cotangent of pi is again going to be 1 or negative 1 over 0, which is undefined. And there's going to be another vertical asymptote there on x equals pi. So if I go ahead and make my graph, we're starting on 0. Here, let's keep going. We got pi over 4, pi over 2, 3 pi over 2, 2 pi. So let me graph my asymptote here on 0. At pi over 4, I'm at 1. Coming up here. Pi over 2, I'm at 0. 3 pi over 2, I'm at negative 1. And then 2 pi, I'm back on an asymptote. And sure enough, what you get is, I imagine, although you may not have thought about it this way, but I'm sure you can, once you see it, you're like, oh, it's feels like it's tangent, but it's flipped upside down. Well, yeah, because cotangent is the reciprocal of tangent, right? So it kind of feels like that's really what you should be graphing. So the period of cotangent is still pi. It starts at x equals 0, back at x equals 0. The other 4 all start at x equals 0. Only tangent starts on negative pi over 2. And then the pattern is asymptote, high, middle, low, asymptote. And these are your 6 parent graphs. So what you need to be able to do is you need to recognize the shape of each one of the graphs, okay? What its period is, where it normally starts, all right? What its pattern is, okay? Because we're going to use those things to actually make the transformed graphs as opposed to transforming the key points. We're going to do it a totally different way which I think is much easier than trying to take all these key points. You got to take 5 of them and move them all over the place. It becomes a lot of work real fast. Instead, we're going to do it in a different way. All right? Those are the things you need to know for now. And as always, thanks for clicking.